It's time. Good afternoon, everybody. Welcome to Chem 170. It's time once again to have some fun with organic chemistry with your host, me, Dr. White. And I have some sad news. This is our last class together. Dr. White said, but you can always stop by and see me or say hello, and we can always set up a Zoom meeting. By the way, seriously, if you ever need my help, email me and I'll help you any way I can. That's something I always do for my students. All right, couple important things. One, next Monday will be the final. There'll be no class. One little before 1 o'clock p.m. I'll send out an email with the password for the final exam. You have until Tuesday morning, whatever time I put in the email. I don't know, did I say noon or no, 1 or 2 p.m. Get it to me. I need to get grading on that. Next week, I'm in a very tight timeline. Also, this morning, I spent a good part of the morning making sure I'm totally caught up, except for the last lab, every lab and test you've handed in. I sent out an email. The deadline for any missing labs is this Saturday. I think I made it 1 p.m. because after that, I'm going to just be too busy. And if you don't get it in by then, you'll get a zero, not good. So please send it in. If you can't upload it to D2L, attach it as a PDF file and email me. And if you're not sure if you're missing any labs, check the grade book in D2L. I've got it current through 10:30 this morning, other than the very last carbohydrate lab, which is due today, and I'll try and get that done by Friday. All right, how do you study for the final? Best thing, use my hourly exams as practice problems. I think in this class or the other class, well, you're gonna have a final review posted on. How you like that? But anyways, second, you can do bad humor on the last class day. But anyways, I consider the hourly exam reviews, put them all together, you've got the final review, except for the very last part with proteins, amino acids. I'll go over that again today. All right, now, someone help me out because I totally forgot. The last 2 days have been super, super busy. First of all, everybody see the test number 2 review? I believe that I go through formation of acetal, hemiacetal on Monday or not? Someone help me out and turn your mic on, or so I knew somewhere around there I ended. Did I do the acid hydrolysis of acetals and ketals? All right, then here's where I'll start. Thank you for your help, Samantha, and everybody else who helped too. All right, these 4 reactions, the previous 2 and these 2, students have trouble on test 2, but on test 4, you did a little better on that. And if you take a hemiacetal, react with acid water, you get the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal. If you take an acetal, where you have, and both of these, the giveaway, and this is the only place in all of organic chemistry where you have 2 oxygens single bonded to the same carbon. And when you add acid and water, they give the same products, not balanced, but the same products. And here we have an acetal or ketal. I don't have R prime, could be hydrogen, it can be. It must have fallen off the page somewhere, bad joke. And when you add acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that. For those who like to balance it, and organic chemists don't, You could put a 2 there. You don't have to. That's why I got it tiny in quotes. All right. Next one, Dr. White's smiling because Dr. White loves Grignards, is if you take an alkyl halide where X is chlorine, bromine, or iodine, react it with magnesium, you form a Grignard. Well, let's have some fun with Grignards. And for your fun and enjoyment on this Wednesday afternoon, what would be the product or products for the following? While you're doing that, let me check something real quick. And I just did. Wanted to make sure I was recording this. All right. I think everybody's done. Let's take a look. Well, I'll give you another 15.2 seconds. Thank you, JC. Time's up. Put down your pens or pencils. Remember, when you're looking at a molecule, look for what's different, what's not carbon, what's not hydrogen, also what's not a carbon-carbon single bond, and that should get your attention. And if we notice right here, it's awfully written. Let me redo this. We have a bromine, and we have an alkyl halide. In this case, R is the rest of the carbons. That's equal to either chlorine, bromine, or iodine, plus a Grignard, a magnesium, getting a step ahead of myself, and you make a Grignard. Remember, if you write this, it's wrong because there's no such thing in nature that exists. So I'll mark it wrong. Make sure the carbon is bonded to the magnesium, the halogen is to the magnesium. Do you break carbon-carbon single bonds? No. Who that was? And therefore I have 1, 2, 3, 4 carbon there. This carbon has the halogen, will have the magnesium, and the bromine is on there. And you know there are 4 bonds to carbon. Now, once you have a Grignard, what can you do with it? Amazing things, which is why Dr. White loves Grignard reagents. And this is one students have trouble with, so pay attention. If you take a ketone or aldehyde and react it with a Grignard, first step, second step acid, the oxygen ran away. That should be H2O. You get an alcohol. And notice you've made a carbon-carbon single bond, something very rare, something very special. In all of organic chemistry, I only know about 20, 25 reactions that you can make a carbon-carbon single bond. How many other general reactions do I personally know? About 350, 400. So it's very small, and there are a lot more I don't know, but I know a lot of them. And let's do this one. Remember, Grignard attacks the carbonyl carbon, opens it up to an alcohol. What was on there stays on there. And the carbon with the Grignard is the carbon attached to the carbonyl carbon. Oh, there's the oxygen. It came back. Have fun. Give the organic product or products 3 points each. And thank you to all my regulars who came today. And thank you to all the rest of you who are watching this video. Quick question. Is it clicking? All right, let's try something. Now is it clicking? Now is it clicking? Now is it clicking? Hold on. I lost myself. How about now? Is it clicking? How about now? I don't know if I like that angle. Hold on one sec. Now is it clicking? When it's near my monitor, this is supposed to go, you can't see it, but my webcam is supposed to go on the monitor. When it's on the monitor, no clicking now, right? Ain't clicking now? I have to find a way to shield this. Let's try something. How about this? Is it clicking now? What? Yes or no? Thumbs up, no. Thumbs up, yes. It's my monitor messing up my webcam, and that shouldn't be. All right. Well, thank you for helping. I bet it's clicking now, right? Hold on. Help. All right, let's get back to work. What do we have here? What's different? Oh, oxygen, double bond to carbon, carbonyl. Carbon's here, carbon's here. This is a ketone. It could have been an aldehyde, but it's not. What do I have different here? Ooh, and it's not the best looking M, but I have a Grignard. Remember, X can be chlorine, bromine, or iodine. Second step, acid and water. This attacks the carbonyl. Remember, carbonyl's great place. That's where all the fun happens. Oops. And this, what's attached to that, still is attached to the carbonyl, R prime or H and R double prime. And this opens up to an alcohol, and we do that special thing, make a carbon-carbon single bond. Do you break carbon-carbon single bonds? No. So it's attached to the carbonyl, is still attached. That's this carbon right here. This opens up to an alcohol. What's my R group? and propyl. Oh, and that's what you get. And that's how you do Grignards. Now, I'm telling you this so you can practice this. Students do bad on this on test and final. Ooh, did I give that away? So make sure you practice this reaction. All right, you take a carbonyl, ketone or aldehyde, react it with hydrogen and a catalyst. Remember, a double bond has one pi bond, whether it's between carbon-carbon, carbon-oxygen, and you can break it, and each atom of the double bond gets a hydrogen. So ketone, aldehyde, hydrogen, and catalyst. Catalyst can be nickel, platinum, or palladium. You get an alcohol. Now, if you had a double bond in this R prime or R double prime, you'd lose it. So H.C. Brown, Dr. Brown of Purdue, back in the late 40s, came up and he created a new reagent that should be LiAlH4, that's a 4, and that's called lithium aluminohydride. That attacks and does the same thing as hydrogenation of an aldehyde or ketone, but this will not react with a double bond. And it does the same thing, gives you an alcohol. And what would be the starting material that I react with lithium aluminohydride and acid and water to make that compound? Have some fun. I think next semester I'll just cover my head with aluminum foil, and maybe that will make the clicking go away. Not. I don't know if I did it or not, but in terms of mentioning it, but after class today, I'm going to stick around, totally optional, and I will give some hints, not hints, tips on how to interview. Students have found it works quite well for them over the last 2.5 years I've been doing this. So stick around. It'll only take about 10 minutes, and we're not going to go till we'll go till about maybe 2 o'clock-ish or so, because I do want to get through test number 3. Maybe not even that long, but we won't go till midnight. All right, if you're done, give me a thumbs up. All right, let's take a look at this. What's different in this molecule? Look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. We've got an alcohol. And I can say the carbon with the alcohol is bound to R prime, but it could be a hydrogen and R double prime. And what do you start with? To make that, and the answer is an aldehyde or a ketone. Here's my carbon with the hydroxyl group. I can call this R prime or R double prime. I can call this R prime, and therefore I have ended up with 5 carbons. I better start with 5 carbons. Which carbon had the hydroxyl group? This one, which is this carbon. And you know there are 4 bonds to carbon, so I can put in the hydrogens, and that's how you do it. And the last part of this, I think I might even finish before 2 o'clock, maybe after we take a break by, well, when I say 3 o'clock, before 3 o'clock. Anyways, the last one I want to talk about is the Law Condensation. And here is my gift to you. If you take an aldehyde or ketone, and for this class, I'll just stick to the aldehydes, the carbon attached to the carbonyl called the alpha carbon has acidic protons. You can remove that and form an enolate anion that attacks the other carbonyl of other aldehydes present and forms something very special, very rare, a carbon-carbon single bond. And here we do that. It opens the other carbonyl to an alcohol, and this is why it's called an aldol. L from aldehyde, OL from alcohol. And this is one students also have problems with, so let me have you try one. And with that, what would be the organic product or product for the following reaction? If it's still clicking, give me a thumbs up. Well, I guess it's not still clicking. And when you're done, give me a thumbs up. Or you can make a silly face if your video is on. All right, I think everybody's done. Let's take a look at this. What do we have here? An aldehyde. And notice on the alpha carbon, there's hydrogens, 2 of them. You only need 1, but for this class, I'll make it easy. And it's the same aldehyde. And we're reacting this with base and water. That means the alpha carbon, this one will lose a hydrogen, that's important, and it will attack the carbonyl there. Notice I've lost 1 hydrogen. Common mistake, students leave the 2 there. That's wrong, because there's only 4 bonds to carbon, not 5. and attacks the other carbonyl, opens it up to an alcohol, and what's attached to that is still attached to it because you don't break carbon-carbon single bonds. In this case, what's our a benzene ring? And therefore, here's my alpha carbon that will attack that. So I'll draw the first aldehyde. Don't forget to put the bonds in the benzene ring, or I'll mark it wrong. And that attached, the second one right there, opens it up to this. And what's attached to that is still attached. And one simple step from a small molecule, I've made a very, very complex molecule, which is always fun and a good thing. Now you know I'm a synthetic organic chemist, in case you had any doubts. All right, what does that mean? It's time to look at test number 3 review. All right, we started for test number 3. I started talking about carboxylic acids. By the way, between now and next Monday, don't forget to play on your own that fun game, circle and name the functional groups. And if you don't have any ones, look at test number 2 and 3 and have fun playing that fun game, circle and name the functional groups, 2 points each. All right, carbon, double bond to oxygen, hydroxyl group, R group, carboxylic acid. How do you name them? You find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add OIC in the word acid. In a carboxylic acid, the carbonyl carbon is always number 1. Therefore, you don't put a number 1 there. Now, there are common names you should know. One is when R is a methyl group, nobody calls that ethanoic acid, it's acetic acid. And you mix acetic acid with water and you get vinegar. Now, when R is H, that's formic acid. And as I taught you, that mixed with water, heat it up is the defensive weapon for the fire ants. I hope I never see one in my life. And finally, when R is a benzene ring, Iupac in their infinite wisdom said, we're not going to change these organic chemists. They've been calling that benzoic acid for eons. Let's continue calling it benzoic acid. So that's both a common and Iupac name. And the question would be, what's the Iupac name of the following molecule? Have fun. All right, I think everybody's done. Let's take a look at it. Look for what's different. Ooh, 2 oxygens. Carbonyl and hydroxyl group, both the same carbon, carboxylic acid. How many carbons longest chain? 1, 2, 3, 4, 5, 6, or this would be 4, 5, and I hope you all agree 6 is greater than 5. That's hexane. Drop the E, add OIC, and the word acid. And on carbon number 3, Dr. White's favorite group, the T-butyl group or tert-butyl group. That's 3-tert-butyl hexanoic acid. Don't forget, ooh, I better do one. There are 2 types of nomenclature question. I talked about Monday, the breakdown of nomenclature, general knowledge, and reactions on the final exam. And therefore, another type of nomenclature question is draw the following molecule, 3-ethyl 2-methyl decanoic acid. All right, looks like everybody's done. How do you decode this to know what to draw? You start from the right, move left. OIC in the word acid tells me carboxylic acid. If this were an E, decane, 10 carbons, I better get to work. Now, I like to write my functional group on the right. You could do it over here. I won't, because I like to do it on the right, and good habits I don't change. All right, 3, 6, 9, 10. This is carbon 1, 2, 3. On carbon 2 is a methyl group. You're a good buddy now. And carbon 3 is an ethyl group, 2 carbons. And I know there are 4 bonds to carbon, so I can work at light speed, warp drive. No, I'm not doing a vaccine. I'm doing numbers. And there we have 3-ethyl 2-methyl decanoic acid. All right, carboxylic acid is an acid. Therefore, if you react it with a base, you have an acid-base reaction. Remember, an acid is a proton donor, and you will get this carboxylate anion. Now, one special one was if you take carboxylic acid and react it with baking powder, which is sodium bicarbonate, you'll get your carboxylate anion, but here the carbonic acid that's formed from the baking powder breaks down immediately to water and carbon dioxide. I hope you all remember the little rocket ship story, which I told you is true. It's one of my fondest memories of my childhood when I was about 5. I can still picture me, I can see me doing it with the rocket ship like it happened yesterday. I can see my friend Dickie Gale, who used up all his mother's baking powder, and boy, did he catch it. Really, she was from Kentucky and she didn't believe in sparing the rod. Oh, did he catch it. But anyways, don't forget that one. Also, don't forget I shared with you my father's recipe for spaghetti sauce. When you make a big pot, put a pinch of cinnamon and put a little bit of baking powder that neutralizes the citric acid and raises the pH and makes it taste milder. Now, how can you make a carboxylic acid? If you oxidize a primary alcohol, you'll get a carboxylic acid. If you oxidize an aldehyde, you'll get a carboxylic acid. O in brackets is a shorthand for oxidation. This semester, I didn't ask you to learn that potassium permanganate, sodium dichromate, potassium dichromate, to name a few, are oxidizing agents. I made your life hopefully just a tiny easier. Now, a really cool way of making a Grignard, I'm getting ahead of myself, a carboxylic acid is react the Grignard with CO2, second step acid and water, and you get a carboxylic acid that's 1 carbon longer than the Grignard you started with. And now it's your turn. What would be the organic product or products for a following reaction? Anybody happen to pass by a gas station? Think about the gasoline they sell has alkanes and also alcohols in it. I hope you did. This is my last day I can convince you to do that. On a serious note, be safe when you go out there. It's dangerous. All right, anybody need more time? Going once, twice? All right, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Oh, look, magnesium iodide. And what do we have? A Grignard. Reacting with carbon dioxide. Second step, acid and water. The carbon with the Grignard bonds to the carbon of the CO2 to form, after acid and water, this carboxylic acid. What's R? That. So I'll redraw it. Then my carbonyl hydroxyl group, and that's the product you get. Now, next I start talking about derivatives of carboxylic acids, molecules that are made from carboxylic acids. And really for this course, I'm really only talking about one, ester. Ester is a carbonyl with an R group, and the carbonyl has an oxygen, and that oxygen has more carbons, R prime. This is called an ester. Now, for Iupac name, you can name R prime as an alkyl group in front, then name, there are two ways. One is the official Iupac 2A, name the carboxylic acid. Think of if R prime was a hydrogen, name that carboxylic acid, drop the IC in the word acid and add ATE. And I had a very sharp student a couple years ago in 170, and he said, oh, I have a good way too, and it's name the alkane, including the carbonyl carbon, and drop the E and add OATE. You still have the R prime. Now, this 2B or not to be, that's the question, I can't resist. But anyways, B2 only works when R is carbons. If R is a benzene ring, then you have to use 2A. Now, there's one ester common name I would like you to know. That's when R is methyl, R prime is ethyl, and that's called ethyl acetate. Nobody calls that ethyl ethanoate, the Iupac name. Everybody calls it ethyl acetate, and that's the more prevalent nowadays molecule that's used for, I take that back. That used to be the main molecule used for nail polish remover. Now with the super hard nail polish coatings, by the way, nail polish is very, very sophisticated organic chemistry. So sophisticated, I don't even have time to talk about it in this class. But next time you polish your nails, you're doing organic chemistry. See, Dr. White did his today. Not. But anyways, don't forget, this is ethyl acetate, and it's one of the two molecules that can be used for nail polish remover. Now, my gift to you is for this class, in an ester, if I ask you to name it, I'll never put a substituent on the R group. It just makes it a little more challenging. And you've got enough on your plate. And what would be the Iupac name for that molecule? I see one person done. Two people. Everybody else done? I assume you are. All right, look at this molecule. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Two oxygens to the same carbon, carbonyl, oxygen. On this carbon, I have carbons. On the oxygen, I have carbons. I'll call R prime. This is an ester. I'll use the, first of all, what's R prime? That's a methyl group. I'll put that in front. And then 1, 2, 3 carbons, propane, drop the E, add OATE. Now, if I give you this one, here you can't use that, I'll do it. It's an ester. Our prime is ethyl. If this were an H, it would be benzoic acid. Drop the IC in the word acid, add ATE, and that's ethyl benzoate. Now that you know how to do ester nomenclature, I can go back and talk about carboxylate anions, or sometimes called carboxylate salts. I don't like using that, I like the anion better. And you name the M plus, the cation, as the element it comes from in front, and then use ester number 2, A or B. And why don't you try this one? What would be the Iupac name for that molecule? 3 points each. All right, I think everybody's done. Let's do this. What's different? Ooh, carbonyl, oxygen there, and a potassium cation. This is a carboxylate anion. And in front, what element is that? Potassium. And then I have 1, 2, 3, 4, 5, 6, 7 heptane. I can use B2, drop the E at OATE, and it would be potassium heptanoate. And if I look at the clock, time flies when you're having fun with Dr. White. Let's take a 5-minute break so I can stretch. You have to do that when you have the kind of muscles I have, older ones. But I'll see you in 5. Remember, at the end of, we should finish up in about 30 minutes or so. After that, it's optional. I'll teach you some good tips on how to interview. See you in a couple. Come back at 1:55. Please. I love that. Time to get back to work. All right, let's get started. We're talking about esters, and you should remember that esters are responsible for all the smells of flowers and for smell and taste of many fruits and vegetables. If you take the banana, unfortunately, this is the sad part, we didn't have lab at ECC this semester, you would have made an ester, and one of them, and you would be smelling them, would be a banana, and you'd be shocked. And I would tell everybody, you see on the label of things, artificial flavors, that's because they make esters and other chemicals that give the flavors. They don't get them from plants or wherever. All right, how do you make an ester? Williamson, uh, Fischer Esterification. Carboxylic acid plus an alcohol, acid catalyst gives you an ester. The carbon with the hydroxyl group in the alcohol is the carbon that will be bonded to the oxygen in the ester. And the question would be, what two chemicals would I react with acid, H plus is acid, to make the following molecule? Your turn. And now you know why I say, or students say, really not Dr. White, that coming to my review helped, because you've had a couple hours this week already of studying for the final, which can only be a good thing. I hope. Actually, I don't have to hope, I know. And when you're done, give me a thumbs up. All right, I think everybody's done. And if we look at what we're trying to make, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, oxygen here, oxygen here. Ooh, carbonyl, oxygen. On this oxygen, I have R prime. On the carbonyl, I have R ester. How do you make an ester? Carboxylic acid plus an alcohol. What's R? Methyl. What's R prime? Isopropyl. Think about that. 6 months ago, would you know what I'm talking about if I said methyl or isopropyl? Aren't you proud how much you learned? I am of you, and you should be. So here would be my carboxylic acid. My alcohol, notice this carbon has the oxygen, 3 carbons. This will have the alcohol. You can turn it around, write it the other way too. I know there are 4 bonds to, that's supposed to be a 3. This is supposed to be a 3. There are 4 bonds to carbon, and I can put in the hydrogens. Time for a public service announcement from me, your host, Dr. White. For the final, remember the following 2 things. 1, and these will be your friends, there's always 4 bonds to carbon. I'll do it this way, 4 bonds to carbon, 4. On every final I grade, you'd be surprised how many problems are wrong, and the student should have caught it if they had thought about How can I have 5 bonds to carbon or 3? There's 4. The other thing, remember for the final, do you break carbon-carbon single bonds? No, except for combustion from test number 1 when you burn something with oxygen. You don't, period. It's rare. Even at my level, it's rare. I can do it, but it's still very rare. And I don't even teach in this class other than combustion. All right, once you have a carboxyl ester, if you're reacting with acid and water, you get back the carboxylic acid and the alcohol you would have used to make that ester. And why don't you try this one for your fun and enjoyment on our last afternoon together. I'm sad. I'll have a drink afterward of water. Oh, by now you know Dr. White likes his Absolute vodka and his Canadian Club, and amaretto too, but not during the week. Never during the week, unless it's an election. Then it flows. Last November, it flowed. Boy, what a tense evening that was. The next couple of days. Let's think about something more cheerful. The sun's out. All right. What do we have here? An ester. Carbonyl, oxygen. On this oxygen, we have carbons on the carbonyl carbon. Acid, water, acid hydrolysis of an ester, and you get back the carboxylic acid plus the alcohol you would have used to make that ester. This is R, this is R prime. Therefore, I'll get back benzoic acid. Plus ethanol. And that's how you do it. All right, let's continue. Now, if you take a carboxylic, I've got carboxylic acid on the brain. All right, if you take an ester and react it with a base, MOH, there are other bases, but for this class, I'm sticking to this where M is either lithium, sodium, or potassium. You'll form not the carboxylic acid you would have used to make that ester, but the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol. Why? Because if you form the carboxylic acid in the presence of base, it forms the carboxylate anion. And why don't you try this one for your fun and enjoyment? Wow, I'm giving you a lot of fun and enjoyment today. I got to charge you extra. Remember, don't forget to make donations to the Save Dr. White Foundation, care of your local somewhere. Forget to hand in the lab. That's due today, sometime today or by Saturday at the latest. And those of you who haven't handed in a lot of labs, don't forget to get them in. All right, let's take a look at this. What's different? Oxygen here, oxygen there, it's the same carbon. Carbonyl, oxygen on this oxygen carbons, on this carbonyl carbons, ester, base, and water, where M can be sodium, which it is, lithium, or potassium. There are other bases, but for this class, I'll stick to that. And you get back not the carboxylic acid, but the carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol. What's R? Two carbons, R prime, one. Therefore, my products are this carboxylate anion and this alcohol. And that's how you do it. Remember, all these general reactions are building blocks organic chemists use to make molecules that are used in our daily life. Next, I talked about an area that's near and dear to my heart because it helped pay my mortgage, a couple of cars, got me around the world, and I had a lot of fun. And that's amines and their derivatives. An amine is a compound where you replace the hydrogens on ammonia, NH3, with alkyl groups. I asked you just to learn the common names, name each R group as a alkyl group, and then add the word amine at the end. Now, there's a special amine you should know. That's when R is a benzene ring and R prime and R double prime are hydrogen, and that's aniline. Now, we're talking about something very sacred to Dr. White because I'm an expert, world expert in this kind of functional group because I worked for a company that made them and we sold a lot worldwide. And that's quaternary ammonium salts. That's where you have four groups on nitrogen with a plus charge and an anion. For this class, I'll keep it to the halide anions. Name each R group as the alkyl group it is. This is a common name. Then add at the end ammonium halide. For chloride is for Cl minus chloride, Br minus bromide, I minus iodide. Now there's something else called amine salts, and that's where you have one, two, or three R groups because R prime and R double prime can be hydrogens, and one hydrogen on the nitrogen has a plus charge, halogen counter ion, and these are called amine salts, and you name them the same way as quaternary ammonium salts. The only difference is for quaternary ammonium salts, you have four R groups. Here, you don't have, you have maximum three. You can have one, two, or three, but never four, because then you'd have a quaternary ammonium salt. All right, how do you make an amine? You take ammonia, react it with a alkyl halide. This attacks there, you form a primary amine. X can be chlorine, bromine, or iodine. If you take a secondary amine, react it with an alkyl halide, same or different. The nitrogen lone pair attacks the carbon with the halogen and bonds to it, and you form from a primary a secondary amine. If you take a secondary amine and react it with an alkyl halide, this attacks, and in the presence of base, because you give off a proton, you don't want that floating around, you neutralize it with the base, you form a tertiary amine. And why don't you have some fun? What would be the product or products for the following reaction? While you're doing that, I'm going to run down to my refrigerator and get a refill. I'll be back. I'm back. All right, assume everybody's done. What's different? Look for what's not carbon, what's not, ooh, a nitrogen. And this one, a halogen. And what do we have here? Notice we have two methyl groups on that nitrogen, brackets CH3 and the brackets 2 tells you there are two of them. So this is a secondary amine plus an alkyl halide. Remember, X equals chlorine, bromine, or iodine for this reaction. In the presence of base, and there are different bases like sodium carbonate you can use here. This attacks that. Let's call it our triple double prime. Remember, for nitrogen, normally there's either 3 bonds if it's an amine or 4 bonds if it's a quaternary ammonium salt. And what's R and R prime? Methyl. What's our double prime? Isopropyl. One way to write it would be this. The carbon with the halogen is the carbon bond to nitrogen. And notice I have 2 + 1, 3, no hydrogens there. And you could have also written it like this, which would have been perfectly correct. It doesn't matter which side has the isopropyl, which side has the methyl groups, same molecule, dimethyl isopropylamine or isopropyl dimethylamine. Now, a very special reaction that's very near and dear to my heart is if you take a tertiary amine, react it with an alkyl halide, in the presence of base, you get a quaternary ammonium salt. And Dr. White has a whole bunch of US patents in quaternary ammonium salts, so they're very near and dear and holy to me. And you should remember, where do you find quaternary ammonium salts? Your fabric softener is a quaternary ammonium salt. Also, it's used as an antimicrobial compound in things like mouthwash. Also, hospitals use them to disinfect operating rooms and other places in hospitals. So quaternary ammonium salts are very important to our daily life to help us. I'm very biased toward them. And what would happen if you reacted two molecules together? R sub T means tallow, and you learned about that. That's carbons 18, 16, 18 real life, but you learned it as 18, with and without a double bond. And time to ruin your life, all your fabric softener and other things like in your skincare, when you see tallow come from beef fat, otherwise known as tallow, or white grease, yellow grease, pig's fat. You shouldn't have told us that, Dr. White. All right, I think everybody's done. What do I have here? Oh, nitrogen. That's a tertiary amine. I can say this is R and R prime. This is R double prime, or any way you want to parse it. Ooh, what's different there? Halogen on a carbon? Alkyl halide. Remember, I don't want to write it there. Remember, X can be chlorine, bromine, or iodine. And in the presence of base, you get a quaternary ammonium salt. You don't have to put the charges down. Dr. White always does. I think it's cool. I try and be a cool organic chemist. And here, notice this is R triple prime. So one way of writing it, I have my two tallow groups. I have one methyl group. I'm going to add a second one, so I can write it this way. Don't forget the anion. Or I could have written it this way also. Two sides have tallow alkyl groups. Two sides have methyl. And for many, many years, this was the only molecule used in fabric softener. They found a cheaper long chain replacement for that. Now, a really neat way of making a primary amine is by reacting a nitrile, that's a carbon nitrogen triple bond with excess hydrogen catalyst. Catalyst, as you know, nickel, platinum, or palladium. In real life and industry, it's just nickel because it's cheapest. And you break the 2 pi bonds in each atom of the triple bond between carbon and nitrogen, get a hydrogen, and this forms a primary amine. And what would you react with excess hydrogen and nickel to form that compound? All right, let's do this. What's different? Oh, nitrogen. This is a primary amine. And I could have also written it like this. And what do you react with hydrogen excess and a catalyst? Remember, that can be nickel, platinum, or palladium. In fact, this was my first project in industry doing this reaction and making it work better. And the answer is a nitrile. And this carbon here is this carbon here. And therefore, what's my R group? That. And notice if you take this molecule, react it with hydrogen catalyst, you'll get this. Notice I have 1, 2, 3, 4 in my final product. I'm not adding any carbons, so I better start out with 1, 2, 3. I did it right, 4. And that's how that works. Now, amines are bases. If you add an acid to it, acid-base reaction, proton transfer, you can have either primary, secondary, or tertiary amine. And here, if R prime and R double prime, either one or both can be hydrogen or they can all be carbons. And I'll just stick to the HX acids and you make an amine salt. Now, next, and for this chapter and finally ending up, I talked about amides. Amides is where you have a carbonyl with R group attached to a nitrogen, and on nitrogen you have R prime and R double prime. R prime and R double prime, both one or none can be hydrogen. This nitrogen in an amide has 3 bonds, common mistake. Students want to make 4 bonds. No. And now with an amide, I didn't ask you to learn any nomenclature. I did teach you about capsaicin, the amide that's found in all sorts of peppers. The more capsaicin, the hotter it is. And I told you about that unfortunate stupidity I did with tasting powdered habanero and how using like dissolved like, I was able to get that out of my mouth real quick. Thank God. Now, how do you make amides? You react carboxylic acid with amine. R prime and R double prime can be hydrogen. And what would be the organic product or product for the following reaction? Did the clicking go away or is it still back? Is it back? What? I think if I move my webcam.
It was gone and then it came back for a second.
Is it back? I mean, it just came back for a second?
Yeah, it came back for a second. It was gone and then came back for a second. Now I don't hear it.
How about now?
Yes.
It must be me. Oh no. I'm radioactive. I turn off the lights while I glow in the dark. I don't want to check that. I'm totally at a loss. Hold on 1 second. Did it come back? Come back? All right, let's do some chemistry. What do we have here? What's different? Carbonyl, hydroxyl group, carboxylic acid. What do we have here? Ooh, nitrogen. It's an amine. And remember here, you have R prime and R double prime, and R prime and R double prime, both one or none can be hydrogen. In this case, I'll call that, it doesn't matter which one you call, R prime, and one of the hydrogens are double prime. And therefore, what do we get? We get an amide. And what's our methyl group? What's our prime methyl? Our double prime hydrogen. You can write it like that, or you can write it like this. And both are the same molecule. Now, once you have an amide, as you learned later on in proteins, amides are the linkage between amino acids that make up our proteins, otherwise known as peptide bonds. So Mother Nature uses that reaction big time. Now, once you have an amide, what can you do? And you learn this is the way you digest protein. Amide, acid, and water, you get back the carboxylic acid you would have used to make that amide, plus the amine salt. Why not the amine? Because the amine salt is an acid. As soon as you get the amine over here, it reacts with the HCl to form an amine salt. And why don't you try this one? What would be the organic product or products for the following? The reason I give these practice problems because it helps you. And also, if I didn't, you could have looked at the reviews on your own. This makes it, I think, a little more beneficial for you. Hopefully a lot more. All right, I think everybody's done. Oh, no, not yet. Not yet. All right, what do we have here? What's different? What's not carbon? What's not? Ooh, oxygen and nitrogen. This is an amide. Reacted with HCl and water. What do I get? The carboxylic acid you would have used to make that amide, but not the amine. You get the amine salt. And remember, R prime and R double prime, one or both can be hydrogen. So in this case, here's my R, and here R prime and R double prime are methyl. So I'll get this carboxylic acid plus this amine. I could either write it this way, Or this way, I'll write it up here. Both would be correct because Dr. White has a piece of paper signed by the Board of Regents of Michigan State University that I know this stuff, otherwise known as my PhD degree. Now, if you react an amide with base and water, you'll get not the carboxylic acid you would have used to make that, because the carboxylic acid in the presence of base will form the carboxylate anion. So you get the carboxylate anion of the carboxylic acid you would have used to make that amide, plus you do get the amine, because an amine is a base and in the presence of other bases, it doesn't react. Next, I started talking about heterocyclic compounds. You should know. And you should know. Don't you love it when I'm subtle? That what is the definition of a heterocyclic compound? And that is a ring with carbon and other atoms such as oxygen or nitrogen. Again, hetero meaning different, cyclic, ring compounds is a ring with carbon atoms and other atoms such as oxygen, nitrogen. I only asked you to learn one, pyridine. That's like benzene, but one of the carbons is replaced with the nitrogen. Stinks like all heck, but it's very useful. It's used to make the antimicrobial compound in my mouthwash, which I showed you. All right, couple things. First of all, I'm not going to do a test number 4 review because one, I just did it last week, a couple days ago before test number 4. And also on Monday, I went through test number 4 answers. Hopefully you were here. If not, stop by my office hours if you didn't get them. And finally, leaving my class, there's some important things you should know. Leaving my class. And there are important things you should know. The first one is, how does soap work? And you should know, first of all, how to draw the structure of any soap. It's a nonpolar tail. If I can spell. Near the end of my spelling goes downhill. If you believe that, I have a bridge downtown Chicago I can sell you. And it has a polar head. And the most important thing, how soap works, is light dissolves light. And you should know water is polar substance. And you learned that in our lab too. And dirt and grease are nonpolar. And because of that, you're not going to wash dirt or grease off your hands, clothes, or whatever with water because they're not the same. And if we look at a piece of dirt and we wash our hands with water and soap, the soap molecules, the tail, because dirt is nonpolar, and the tail of soap is nonpolar, And because light dissolves light, it lines up all around and a lot more of these. So it totally surrounds the dirt. And now you form, and you should know, this is a micelle. When I took my shower this morning, I was the only one probably in my suburb that thought, oh, I'm making micelles. Yes, I'm an organic chemist. And now water looks at the micelle, and the micelle looks polar to water, and water says to the micelle, I'm polar, you're polar, let's go down the drain together. And lo and behold, your hands are clean or whatever else you were washing. That's the first thing you should know leaving my class. Next, leaving my class, you should know how to describe with words in a general reaction what happens when you eat something with fat or oil in it. And in your stomach, there's acid and water. So you have acid hydrolysis. What functional group is in a fat or oil? An ester. And the general reaction, ester, acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. Everybody got this copied down who want to, or go back and look at the video? Next thing, leaving my class, you should know how to describe with words and a general reaction what happens in your stomach when you eat a carbohydrate. And here you have acid hydrolysis, again, acid and water in your stomach. And what functional group holds together glucose and compound starches and other carbohydrates? And that is an acetal. And the general reaction, I'll do it for a ketal or acetal, because you learned this for test number 2. You get back the aldehyde or ketone you would have used to make that acetal or ketal plus the alcohol you would have used. You don't need it to, but years ago I had these two twin sisters, got all bent out of shape when I didn't, so I always pop it in now because I don't need bent out of shape students. Not fun. And the last thing you should know, leaving my class, is when you eat a protein, how do you describe with words and a general reaction what happens when you eat a protein? And there, what's the functional group in a protein, or what holds amino acids together? That's an amide. So it's acid hydrolysis of an amide. And here, the general reaction, amide, and since in our stomach we have HCl, I'll use that as my acid. You get back the carboxylic acid you would have used to make that amide, and you get back the amine salt of the amine you would have used to make that amide. Now, One of the things I didn't have, but I'll do right now, I'll go over again, and that's amino acids. Key things, I think there are 4 or 6 points in the final on amino acids and proteins. How do you draw an amino acid? That's a carboxylic acid, and on the alpha carbon, you have an NH2 group, and that's an amino acid. The alpha carbon is the carbon bonded to the carbonyl carbon. Now, when R is not, whoop, pushed the wrong button on my pen. Holy crap, oh, get rid of that line. Thank you. When R is not hydrogen, you have a chiral amino acid. And what functional group is in proteins? And that's an amide. That's the linkage that holds amino acids together. All right. Remember, next Monday will be the final. It's critical you get it back to me by Tuesday. If you don't, I'm going to take off a lot of points. I put that in the message. This is one I need your help. I'm giving you a lot of extra time, more than other faculty. Now, first of all, stick after class, even though I'm going to do my normal goodbye, but stick around for those who want, and I'll give you some pointers how to interview, and they help a lot of my students. But if you think a long time ago, when we started, I said my world of organic chemistry is your world of organic chemistry. You don't know about it, but now my world of organic chemistry is your world of organic chemistry, and you do know about it. You know more than most Americans or people on this planet. It's knowledge nobody can ever take from you. And with that, I'm done. I've done my job. Hopefully you've done yours. Thank you for being in my class this semester. If you like what I did, go to ratemyprofessor.com and put something down. If you didn't like what I did, go to ratemyprofessor.com, put something down. If you really, really, really like what I did, send an email to the Board of Trustees. You can find their email address on the ECC website. And with that, I'm just about done. Quick thing, Monday, no lecture. I'll send this out in the password email. On Wednesday, I'm required by the contract to have class. You don't have to show up unless you want to stop by, say hello to Dr. White. That'd be nice. I'll stick around for about a half hour, 35 minutes. Nobody shows up, I'm out of here. But anyways, hopefully for sure by Sunday, hopefully by the end of the week, I'll have your grade and all your points and all your information in D2L, and I will send out an email to let you know to find it. With that, one final time, that sounded awful. Gehen gesund, be healthy, stay healthy. Don't forget to use your tests as practice problems to study for the final. And with that, I'll say, gehen gesund. Goodbye.